All right, good morning, afternoon, everyone. So we will be doing the DFlow Workshop 2 today. So we'll just give it a couple minutes for everyone to click through and get into the GoToWebinar format. My colleague Rosie is also tuning in as an administrator. So if anyone has any questions, she'll be able to kind of address those to me as they come up. So probably the main thing is hopefully everyone who was intending to follow along with DFlow has been able to install the package. If not, please just post that in the chat and then I will try to go over how to quickly do that once we get started. All right. So more people are coming in, so I'll go ahead and just do the introduction and then we'll move directly into the DFlow programming. So this is the second workshop that we've been putting on to try and get everyone a little bit more familiar with some of the unique aspects of DFlow and how to better utilize it in order to develop your own research protocols. So my name is Eric Jenkins. For those of you in North America, we've probably met either virtually or in person before. Outside of the European region, you would probably be more familiar with Rosie. So we work together a lot and do a lot of same things for our regions. So our first workshop was with Hassan, who is the Clinical Applications Manager for the Asia Pacific region, and he went over how to display and utilize real-time feedback. So we linked that YouTube video in the initial email, so if you didn't get a chance to check that out, that would be a good time to take a look at it after. And what this workshop will build on is a couple of the things that Hassan covered in that workshop. Which brings us to our second workshop, which is today, and we will be creating and managing global events. And coming up in around February 2023, Rosie will be hosting a workshop that focuses on the Lua scripting aspect. So that's certainly something that I get asked questions a lot when I'm doing trainings with our devices, is how to better use the scripting. So we'll have more information to come for that. All right, so today's research protocol that we will be working with, so of course it really helps to have a good understanding of what we aim to do and how it's going to look before we start building it. So it's really good to get that framework going so that can help us give some context to what we want to do. So this is just from the email that was sent out. So essentially what we want to have is a protocol where we have 3 different conditions. In this case, it's treadmill speeds. And each of those conditions is going to be recorded for X amount of time with a delay or with a buffer in between to allow for the paradigm to change or data writing to happen in between. And so the primary goals that we'll be using today are to create some global events, create a parameter button within the runtime console, and then we're going to tie these events to the modules themselves. And we'll also set up automatic recording of our selected data. And then we will display if the system is recording. So to give it some additional context, this is what the protocol that we'll be building today will look like. So there are, of course, other ways to do protocols beyond just changing treadmill speeds or split belt. It can also be things like adjusting the platform motion, so pitch, sway, something like that. So there's a lot of different things that you can do. The main idea of this task is that you can apply it to other things where you want to have an automated protocol from start to finish. So what today's will look like is once you click the play button, the treadmill will start to get up to our first speed, which is 1 meter per second. And once it's at that speed, the button that we create to start the recording will start a 10-second recording. And so you can see right here that in this case, Vicon is also simultaneously recording, as well as there is a record image on the DFlow projector screen here. And so you'll note that it's recording while the treadmill is at speed. Once that record light comes off, the treadmill will get up in speed for a couple seconds, and then it will start recording again. So the entire process essentially will be completely automated to ensure that all of the data collections are the exact same length, which really helps on the post-processing end if you're doing things outside of like, let's say, Goat. So if you're doing things in MATLAB, or Python or any other type of scripting coding language. Okay, so this will look a little bit different than the package that was sent to you, because this is the finished package. So this is essentially what we are going to get building today. So I will go ahead and change my screen, and we will go to the DFlow screen, and then we can just follow along there. Okay, so this is what you should see when you downloaded and installed the package. So right now, I don't see anyone in the chat that had any issues with doing that, so that's great. So we can go ahead and get started with making our changes to the application. So one of the first things to go over is we already do have a few modules in the workspace. So I want to just kind of touch on what some of those do. So as I mentioned, for the next DFlow workshop, we'll be doing scripting. So scripting is a way that you can use just like a very basic computer programming language to control all of these things. But what we have here is a more simplistic and easier, it's more approachable and easier to see everything that's going on, whereas within the script, it's listed all down within the coding. So it's a little bit less easy to see everything that's going on. So for the treadmill control speeds, what I have here is just a very simple way of doing it using the expression box. So you'll see that in channel 1, 2, 3, and 4, we all have our representative treadmill speeds that we have. So since we're just doing 3 walking speeds and 0, of course, to stop the treadmill, we are going to connect these to a switch. And so what the switch will do is it can take a number of different inputs and then only provide one output, which in this case is ideal because what we want to have control is the treadmill. And now the treadmill's belt speed can only accept one input. And so you'll see from the connection from the switch to the treadmill, it's on channel 1. So the way that channel 1 is able to provide all of the information for the various treadmill speeds is that all 4 of our treadmill speeds, so all 3 walking speeds and stopped, go to their different set numbers, but the channel 1 is always the same. So that means that when we change the set number of the switch, that it's always going to be sending channel 1, but just different set numbers. So each one of these speeds will represent a different set. That set gets sent as channel 1, and then that output goes to the treadmill. So that should generally explain kind of what's going on over here. So this is essentially our main treadmill parameter control. And then connected over here to the display, if you have, I guess I should have explained, if you have 2 screens, you should see one that looks like the DFlow workshop base. So like one that looks like the one that looks like this screen, and then another one that looks like the DRS, which I will drag over into the workspace. And so it looks like this. So you can, of course, make the dflow workshop a little bit smaller if you're only working with one screen. Otherwise, if you have two monitors set up, then you can have the DRS window on the other side. So when we go to run through at the end, I'll bring the DRS window back over into this screen. Okay, so the first thing that we want to do now that we have our three different speeds that we want to go and run with, what we want to do is start building our global events so that when we bring these global events together, that they're ready to pull from right away. So when we create a module and we want to have it set up to certain events, if you haven't created the event, it won't be able to quickly link it, and you'll have to go back and create it again anyways. So down here on the bottom left corner of your dflow screen is going to be the global events. And so if I open up the runtime console with F2, you'll see that there are a number of global events here, which are also connected to the runtime console. So you'll see that play, stop, reset, calibrate, and action, they all show up automatically here. So these global events are able to control everything that's going on in the workspace. And one way that we'll start to check things later as well is when you single click one of the global events, it highlights in yellow on each module what that action is doing. So it's a good way for when we're using these global events and not everything is wired and connected together, that you can get a better understanding of what that action is going to do to all of the modules within the workspace when it happens. So we have our three treadmill speed conditions. So 1 meter per second, 1.25, and 1.5. So we need start cues and stop cues for each of those. So I'll click on the paper logo, which will create a new event. And so from here, we'll go ahead and name it start 1 meter per second. Then we'll have a stop 1 meter per second. And then we'll do the same thing for 1.25 and the 1.5. Okay, so I will give everyone just another minute or so to type those in if you haven't done them yet. But as you see, once we go over them and highlight them in blue, we don't see anything in yellow yet, and that's because we haven't assigned anything to work with them. But now that they're here, that's good for us because now we can more easily get them to be used for what we're going to do next. So when you're doing some of your protocols, often you want a set amount of time to be recorded so that all of your trials are the same length. So for that, what we'll do is we will go over to the right-hand side of the screen. So yours is probably looking like this. So this is the top. So most of what we're going to be doing today is down in the blue section. And so these are essentially kind of our resources that we can use. And so we'll want to bring in a stopwatch. And so this stopwatch is going to be the key controller for what we have for everything. So it's going to be running the start cues and stop cues. And so we're actually going to need 5 of these and not just one. So if you want, we can go ahead and bring in the 5. And I'm going to stagger them like this because down here at the bottom, so these will be our essentially like start recording speeds. This will be the little 5-second buffer that I discussed. This will be the next record. We'll have one more buffer. And then down here, we will have the last one to start the condition. So as you can see, it already is getting to be a lot of modules in there, and we're not quite sure what everything is doing. So what you can do is drag a box over all of the modules, and if you right click, you can create a group, and you see we already have 2 in here, display and treadmill speed control. So we'll go ahead and create a new one, and so this will be our timing. And so we can say that what this is going to do is it's going to time all of our trials and then create the buffer. And so we can change the color, but we'll just keep it blue for now since all the stopwatches are blue. And when you click OK, we now have some information. And if you go to move one individual module, it's going to extend this blue box so that you know everything is grouped together. So this is a really nice way to keep your protocols organized, and that you label everything so that you know what everything is doing when there aren't direct connections, just like how these stopwatches are going to be. So as we start to build our stopwatches, one of the things that I find really useful to do when building a larger protocol is if we go over to the right-hand side of the title and rename it from stopwatch to the action that we're going to do. So this first stopwatch is going to be responsible for starting our 1 meter per second. So I will go ahead and put start 1 meter per second, and now it assigns a label to it. And with that label, it's going to be very easy to see that we know exactly what the stopwatch is doing. So what we want the stopwatch to do, if we double click and open the module, each of these 3 down here at the bottom, these are going to be our start cues. So for this example, and the interest of time, they're just going to be 10 seconds long. So this is essentially your data collection time. So if we hit 10, normally with dflow, if you have a blue box, it means you have to hit enter for that input to go. But here it stays white. So once we hit enter, you now see that the stopwatch changes to our 10 seconds. So now what we want to do is after 10 seconds, we want our data collection to end, and then we want our 5-second buffer to begin. So what we're going to do is on 10 seconds, we want it to count down, and most importantly, we want it to trigger an event. So when it means trigger an event, it means that it's going to broadcast one of these global events that we created on the side here. So since this is the start 1 meter per second, at the end, we want it to be the stop 1 meter per second. So now this will be going from 10, counting down, and at 0, it will trigger an event, and that's the stop meter, 1 meter per second. So the last thing that we need to do is over on the right-hand side of the screen, under the module properties, you'll see that by default, most modules that you bring in are going to have an action of start on play. But for us, we want to control when this stopwatch actually starts. Otherwise, the recording is going to start immediately when you hit play, and that's not useful for us. So we want to change the action of play to none. And so we're actually going to do that for all of these stopwatches up here, is remove the play action, set it to none. And so for start 1 meter per second, we want it to stop. And then it's also convenient, especially if you want to have a stopwatch doing multiple things within a protocol, then you want the event that it triggers. So in this case, stop 1 meter per second to stop and reset. So one way that we can test out that our actions are actually working how we want is if you go over to start 1 meter per second, we see that it's going to start. So we can actually broadcast this event. It's going to count down from 10 until 0. And then once it gets to 0, it will go automatically back to 10. So that means that that stopwatch did exactly what we want to do. So now we will go ahead and go through each of these stopwatches. I'll add the labels to them, and then we'll work through setting up the timing for them. So this is going to be our buffer 1. And so if we go ahead and open this up, and for right now, it'll look a little bit busy, but I will keep all of the stopwatches open as we're building this, and then I'll close them out as we get towards the end, just so that you can see everything that's being built in place. So for buffer 1, the first thing that we can do is remove the action of play to none, and so this one, it's going to be a little bit backwards. So our buffer, we actually want to start when the stop 1 meter per second goes. So this is another nice thing about keeping your protocols in a line or in kind of a linear fashion, is that we're going to go just exactly like this. So by keeping these open, we can see that on stop 1 meter per second, we want this to start. So that's what we have set up over here. This will be our 5-second buffer. So hit 5, enter. We're going to do the same thing, count down, trigger our event, and then at time 0, so our next cue is going to be the start 1.25. So we want to go to start 1.25 meters per second, and we can continue on with these guys. So we'll go ahead and rename this one to start 125. And we will come down here and remove the action of play. So this is often where things kind of get confusing with all of the actions that we can't exactly see. So for here, like the treadmill connected to the display, we have a visual line that tells us that something is going on. Whereas when we're using global events, it can be a little bit more nebulous because we don't see everything that's going on behind the scenes. So it's always good to check what the actions are doing within a module to make sure that it's triggering when it's supposed to, and it's going on, off when it's supposed to, and that it's connected to the correct event. So for start 125, we want it to start on start 125. And at the end, it's going to trigger the stop 125. So then we can go ahead and do the stop and reset. And so the this start 125 meters per second, this is coming from the previous stopwatch, the previous buffer, that it's broadcasting this event. So we'll do the same here. And since this is a trial condition, we'll set it up to 10 seconds, same thing, counting down, trigger event at 0. So this one is going to trigger our next buffer. So we're going to have it a little bit off screen here. So this will be at stop 125. Carrying on, our next stopwatch. Here's our buffer, 5, count down, 0. And so for this one, we want it to end with stop. We want it to, broadcast the start 1.5 meters per second. And we want it to play. So we'll change our actions here. We want it to play on stop 125 and on, and on start 1.5, we want it to stop and reset. So we should be good there, and I'll open up our last one here. And so this will be our last timing. So this will be 10-second trial, countdown. And so once the 1.5 meters per second data collection ends, what we're going to have it do is it's going to revert back to the treadmill 0, and it's essentially going to stop the treadmill and stop the application. So at the end, we will do stop 1.5 and make sure that our actions are all correct over here. So we'll move the play, and on start 1.5, we'll have it start, and on stop, we will have it stop and reset. And go ahead and add my labels too. Okay, so the one thing that we can do to get everything going and make sure everything kind of cascades nicely is we can actually go to our start 1 meter per second queue here. And essentially what we should see, if everything is built up correctly, is this will count down and this will start. So this will get to 0, this will start, 0, start. So everything should be nice and follow along. So if we go ahead and test out the broadcast, the start 1 meter per second, and just wait for it here. And so now we have our next one that's going, and we see that this one stopped and reset. And I see I forgot to stop and reset this buffer, but that's okay. We can go back and easily fix it. So now we have a countdown here, and that should trigger this one. It's good. And then we'll make sure that that one starts this last one. And so as you can see, it's very important to make sure that you keep up with everything, because even as I did this, I forgot to add our stop and reset queue. So I can go ahead and add that back here. So back to buffer 1. So at the end, it's starting the 125. So now I'll go ahead and add my stop and reset. And so even though this one went negative, that's okay, because it's not triggering anything else. So now that we saw all of these events working off one another, I'll go ahead and close them out and free up our workspace. So before moving on any further, are there any questions in the chat about anything that we've gone over so far? Okay. I don't see any, so we'll go ahead and move to the next step. So what we have now is we just have our timing cues. We haven't actually connected them to the switch yet, which is going to be what controls our treadmill. So if we go to our switch, we actually don't need to double open it, but if we go to look at our actions panel, you'll see that on play, it's going to activate set 1. So if we open up our connection wire here, so just clicking on it, and you'll see the connection editor pop up at the bottom. And if we open up our expression, we can double check and make sure that our numbers are the same. And then we can also see what outputs are coming from the expression. So 1, 1.25, 1.5, and 0. So in our switch, over here, we're going to be controlling the actions panel again. So what's going to happen now is on play. So when you hit play in the runtime console, which is F2, so when you hit play, the switch is going to automatically activate set 1. And as we look over here, that is the 1 meter per second condition. So when you press play on the runtime console, the treadmill is automatically going to get started and get up to speed at 1 meter per second, at which then we will add our, we'll have a parameter button up here, which will start our data collection. So when you hit play, treadmill gets up to speed, the person walks for a couple seconds, then we would hit the start recording, and then that starts the recording at 1 meter per second, and then cascades through our various time stops. So on play, we want it to activate set 1. And so now we see channel 2. So act on set 2. This is our start 1.25. So we're going to go to start 1.25 and make this activate set 2. And then our next one is going to be the 1.5 condition, which is set 3. So on start 1.5, we want to make that set 3. And so the last thing to do is, in order to essentially close out the data collection and get the treadmill back down to 0, is after our start 1.5 meter is active, on stop, so after that 10 seconds of data collection has gone on, now we want to activate set 4, because activate set 4 is over here, which is going to be our treadmill at 0 speed condition. So on play, it will go up to 1 meter per second. On 2, it will go to the 1.25, then 3, which is the 1.5, and then at the end of that one, we'll be activating set 4, getting the treadmill back down to 0. So now we have everything that we need to get started, minus the one button to actually trigger our start 1 meter per second. So this button that we've been broadcasting over here, we're now going to take that into our runtime console. So I'll keep the runtime console up here for now so that you can see what happens. So over here on the modules panel, if we go all the way down to the bottom to the tan section, if we bring in a parameter, this is what allows us to actually create things within the runtime console. So in the parameter, you'll see right now we're just in the default tab, and that's fine. That's all we need for this. So for to do this, the thing that makes the most sense is probably to use a button. So we'll go down to create a button, and so we can go ahead and give it the name that we want. So this will be like the start recording. And so the name that's here is actually something that can be referred to within the script, whereas the caption is what we're actually going to see. So this is what we want to be most legible. And so the size essentially just means, does it take up 100% of the space in the runtime console left to right? So this is a good, if you have a number of different conditions or options that you want, that you can have the buttons all in the same row, but just side by side and smaller. So since we only have the one, we'll just leave it at 100. And so because we created all of our global events when we first started, we will go down here to start 1 meter per second. And if for some reason when you create a parameter, you just think of an event that you want to add it to later, you can always just hit OK, create your new event down here, and then back on the parameter, if we reopen it, now you can go back to the event that you just created. So if you forget to add an event, so you see that they're all there now, but if you haven't added one or you're coming up with a new one, then you can always go back and add that later. So we have our start recording, and on click, it's going to start our 1 meter per second. We'll go ahead and hit OK. And if you look in the runtime console, you'll see now that we have a button that says start recording. And so one of the benefits of utilizing the parameter module to create buttons and sliders and things like that is that everything that you can control within the data flow editor here is now able to run off of the runtime console here, so that you always have the stop button in case the participant out on the system needs a minute to cool off, stop to settle down. You can always hit this. So it's always good for safety to have the runtime console up, and then from there you can have all of your various controls within the runtime console. So right now we have essentially everything that we need to do our 3 conditions and do the recordings of them. So the last thing that we can do is over here in the display, you'll see that this is our text that shows up as recording. So we haven't done anything just yet here. So now we only want this, let's say we want the participant to know that they're being recorded, or have something else going on while the system is actually recording. So you'll see that it's always going to be hidden now, but on our start condition, so when that block of trial is going to start, we can show, and so we can do that for all of the events. So we'll go ahead and show. And for all of the stop events, we want to hide. So because this says that it's recording, we only want it to show that it's recording when all of those 10-second data collections are going on. And then we want to hide when they are not going on. So now we have everything set up to go for the recordings. Now, if you were to record simultaneously in Nexus, that's another couple steps that I won't get into now. But if you do have questions, you can feel free to ask me later. It's very simple to do. It just utilizes the fidgets module up here, and we can use a script or something else to pull that in. But for right now, what we'll do is, if we want to do some recordings from the motion capture, if we bring in the motion capture module, then we have the option to, so now we have the option to, over here, we can, on our start recordings, we can actually, we can start gate recordings, or we can set it to record. So depending on if you have, let's say, the HBM that you're utilizing, or if you just have your own marker set, you can bring in, you can actually start recording from the motion capture module. Or if you have additional things that you want to record, you can come down to the record data, or even the record video if you have the Basler live video cameras. You can also bring those in. So the same exact principle would apply, that we want to record our data with the events that are queuing our start and stop actions. And so we could set up the timer to record, and then at the stop queue that corresponds with it, we can have it to stop. And of course, in here, you would assign where you want your file to be named, where you want it to go. And then this is where you would need a wired connection. So you would essentially, let's say you want some data from the motion capture, maybe you want to follow along with the treadmill speed. You can connect those two modules down to the record data. And if you rename your channels, then your output will be in very easy to read like Excel file, so a tab separated or a comma separated. So very easy to load into Excel to manage your data, or to feed to something like MATLAB and post-process that way, so that you have your speed information along with all of the mechanics that you're getting from the various different speeds. So to look at some different conditions of gate parameters there. So lastly, what we'll do is, now that we have everything going together, I will bring in our DRS window back over here. And so then we can just run through and make sure that everything shows up as it should. So as you see, the DRS window is what would be in front of the participant as they're on the system. So what I'll do is go ahead and stop and reset the application, just to make sure anything that wasn't reset is reset. And so I'll go ahead and hit play. And when I do that, the treadmill speed should go up to 1. And so now we can just go ahead and hit our start recording button whenever we are ready to begin the recording, and we should see a recording pop up here. And this will start our cascade of 3 different conditions, and then ultimately ending with the treadmill stopped at the end. So I'll go ahead and hit the start recording. We see that we're recording here. And so then after about our 10 seconds, the recording should disappear. The treadmill speed will increase, and oh, let's see. Okay. So that's another good thing about testing out your application, because I see that I tied the switch and the treadmill speed incorrectly. So we can go ahead and fix that, and then we will check it and try it again. So I'll go ahead and stop and reset the application. So I think the issue is happening between our switch and our treadmill. So we actually want these to be all on the stop cues instead of the start cues. Because once we run through the 10-second trial, we want that to engage the treadmill switch instead of it starting on the next one. So let's go back. And so we'll go ahead and remove these. And so active set 4 is actually going to be okay, because at the stop, we do want it to stop. So now at the stop 1 meter per second, this is where we want to engage our set 2. So, so we hit play, it's going to start at 1. And instead of starting on the next cue, we want it to go right at the end, so that that 5-second buffer that we have allows the treadmill to speed up before we start the recording. And so on the next one, now we will do that. And now, so I will go ahead and bring in the DRS window. We will stop and reset, and now we will check again. So we are at 1. I'll go ahead and hit the start recording. Then we should get our 10 seconds. And now when we do when the recording disappears, the treadmill speed should automatically switch up. There we go. So now it gets up to speed, and then our recording should start back here. So even though I've dealt with the modules a lot, it certainly can be a lot to take in, since you don't have direct connections to everything, how everything is connected, because they're connected through just the global system and not direct linear connections, which makes it a little bit tricky to kind of follow along. So it's certainly easy to misstep, as I did earlier. But there we go, and now our treadmill speed is back down to 0. We can go ahead and stop the application. And so from there, we have a very basic 3-condition protocol setup, completely automated. So pressing play, starting the process of recording, and then we have 3 equally timed conditions that will be running. So of course this can be applied to different things. You can include some perturbations in here, swapping the belt speeds, so controlling left and right separately, altering the pitch and sway or the platform movement of the system, and connecting these into the timings and doing something similar to that. So it can be really expanded to not use the treadmill, but to do even balance tests and things like that as well. So I don't see anything down in the chat, so hopefully everybody was able to follow along and get the protocol up and running. If not, please post any questions, or additionally, I'm happy to answer any other questions that you might have.
Thanks, Eric. Super nice workshop today. If there are no questions, I think that means that everyone managed to follow. Something to remind you all of is that this workshop will be available from tomorrow to view offline at your leisure. So if you need to see it again and you want to pause it from time to time, of course, that's totally fine. If you've not got much DFlow experience and you couldn't follow along, then of course, feel free to watch it back in your own time. I see that there is one question popping up here from Nicholas Bison. When I press play, it doesn't start the treadmill. What did I miss? Eric?
Yeah, so there could be a couple things. So if you're actually in the lab, Nicholas, then of course without a treadmill, nothing will happen. But so when on the treadmill module itself, uh, in the actions panel, so it should start on play, and then with the switch connected. The play action should activate set one, and activating set one is our 1 meter per second. So in the base application that was sent, this all should have been connected. So from here, the play on treadmill should be set to start, and then that corresponds to a speed of 1 on the actions. If you still can't quite figure it out, just send me an email after this, and I can take a look at your DFlow application and walk you through where something might be off.
Great. Hopefully that helps. Feel free to respond in the chat, Nicholas, if that helped you. Eric, what's the best way to send applications? If someone wants to send you an application to have a look at, in what format should that be?
So I forgot to mention this at the beginning. So when you opened your the CPK, that's a package. And so essentially what that is it's the DFlow version of like a Windows zip folder where it has all of the subfolders within. And then when you load it into a different DFlow location, so if you take it from one system location to another system location, then everything will load, including like the scenery, or somebody's added different objects into the work environment. That stuff will load from the package. So if you have something to send to like Rosie or myself or any of the clinical applications team, what you would do is go to File and save as a package, and then that's essentially saves the zip folder. And so of course, like here, it'll ask if it'll make sure that you saved everything. And so we will go ahead and I'll just rename this. So if we go to File, Save Package, and you'll see here it saves all of the DFlow, which is what we're working in here, so mainly the application, but it also shares the scene information, which is going to be really important if somebody adds additional assets that another location doesn't have, and those will pop up down here in the scenes. And so we'll go ahead and hit OK. And so now we have the fully zipped CPK, which is what was sent to you all. And then to do that, we go through the process, importing the package. It saves as a project, which then saves as all those subfolders to give everything into one space.
Okay, perfect. I don't see any more questions coming in, so we'll start to wrap up the session. But before we do that, Eric, I have one more question for you, which is, do you have a top tip for new DFlow users when they're developing?
So I would say some of the things when you start looking at how to develop your own protocols is if you, of course, there's always the help menu. So if you go to an individual module, if you press F1, it takes you directly to that module's help. But one of the things that I find useful is if you open up an application in DFlow, like one that was already created by Motec, then you can start to open them up and see how they interact with one another. So you can start to see how things are connected, and then start to almost like reverse engineer some of the applications and get a better understanding of how things are connected and how you can start to develop your protocols in the same way. So I would probably say those are the two big tips that helped me.
Great. I think from my point of view, I would add to that, start small. So when you want to create an application, don't start by adding 16 different conditions, but maybe as we've seen here, just a few different conditions, and then of course you can build on that later. But it's much easier to start in this way with something kind of small and build it up from there. Okay, so if there are no questions coming in, I think that will be it for today. Please do fill in the survey at the end of the session. That will help us to get some ideas for the next session. We hope to see you again in around February for workshop part 3. Thank you very much, and I think that we can close the session unless Eric, you have any final
Nope,
words.
that's it. Thanks everyone for joining. Hope that was helpful. And if you have any questions, feel free to reach out to Rosa or myself, and we'll be happy to talk with you then.
Okay, goodbye.
Bye.